the last type of optical instrument that we need to concern ourselves with is the concave lens. So a concave lens is designed to divert light away from the focal point, so the exact opposite as a convex lens. You'll also notice the shape here for a concave lens. It looks like two back-to-back concave mirrors, I guess. It's thinner in the middle than it is on either the top or the bottom. So since it's designed to spread light away from the focal point, you might see it called a diverging lens. It bends the rays away so that they don't hit all in that single point. So like with the convex lens, light that passes through the vertex doesn't bend. It's able to go through in a straight line. So note that the focal point here is on the same side of the lens as the object. So since we're working with lenses, focal length is negative. So diagram here shows us, and as the two equations for lenses and mirrors would tell you if you were able to plug in some numbers for it, that the image here formed by this guy standing outside the focal length of a concave lens, the image is virtual because it's on the same side, and he's standing upright. You can see him kind of in there very, very faintly. So that means that our D prime image distance is negative, and H prime and magnification are both positive. So note that the object's actual height, or the boy's actual height, is bigger than his image height, so our magnification has to be less than 1. It made him a lot smaller than he actually is. So in the geometric optics unit, it's not a lot of difficult material, it's just a lot of very particular things that depend on what kind of instrument you're working with and what information you're given or asked to find. So there's a lot to absorb, and remembering which rules apply to which mirror and lens can be difficult at times, but it's very systematic. So once you get an idea of what's going on a larger scale, it's easy to figure out the smaller details along the way. So 3 things that'll help you really get the big picture. Number 1 big thing, learn how to draw ray diagrams. From what I've seen, looking over the mirror diagrams, they looked like they were pretty good. A few of us are still trying to figure it out, but that's where the equations will come in. They'll help out a lot with that. So look over diagrams of the 4 kinds of instruments and practice drawing them. Remember, light is going to refract through lenses and reflect off of mirrors. Remember, convex lenses and concave mirrors focus light, while concave lenses and convex mirrors spread it out, they diverge it. Alright, important tip number 2, learn how to use your equations. So there's only 2 of them, really simple algebra associated with each of them. Get familiar with them. So you could walk into the AP test only knowing the 2 equations for lenses and mirrors and still know absolutely everything that you need to know. So just remember where F is positive and negative, and the conventions for which side of the instrument is positive or negative. So important there. Everything has been condensed into a handy little summary table, and it would really help you out to memorize this. Like I said, there's a lot there, but if you memorize it, then everything is just easy as could be. So it tells you, should your D prime be positive or negative? Does that mean real or virtual, upside down, upright? So this table will help you out a lot in the long run. So the questions you'll run into are usually two kinds. It'll be a quantitative question that expects you to apply one of the equations that you have, or it'll just be simple qualitative stuff asking you to determine where does the light get focused, would it be real or virtual, upright or upside down. So knowing the equations would help you answer the first part, the quantitative. Knowing how to do array diagrams or memorizing the table would help you out with the more qualitative stuff. And that wraps up geometric optics. So next week we'll be getting into wave optics.